Good morning, everyone. We are here to present the topic about rocks.
What is rocks? A rock is a naturally formed non-living earth material. Rocks are made of collections of mineral grains that are held together in a firm, solid mass. The different colors and texture of rocks are formed because of the minerals given to it.
There are three types of rocks, and those are igneous rocks, sedimentary rocks, and metamorphic rocks. Let's start with igneous rocks.
Igneous rocks form from cooling and solidification of magma. Igneous rocks are formed from the solidification of magma, which is a hot 600 to 1300 Celsius or 1200 to 2400 Fahrenheit. Molten or partially molten rock material. Examples are basalt, granite, rhyolite, and andesite. When hot molten rock crystallizes and hardens, it forms igneous rocks, which came from the Latin word fire. The molten rock originates deep beneath the earth around active plate borders or hot areas, and then rises to the surface. Depending on where the molten rock hardens, igneous rocks are classified as either intrusive or extrusive. In intrusive rocks, some of the magma may sustain volcanoes on the surface, but the majority is trapped under the surface, where it cools slowly over decades or millions of years before solidifying. Slow cooling allows individual mineral grains to develop over a length period of time, resulting in a relatively large size. There is 5 types examples on intrusive igneous rock structures. First is dikes. A dike is an intrusive rock that generally occupies a discordant or cross-cutting, crack or fracture that crosses the trend of layering in the country rock. And the others is sills, lacolutes, volcanic necks, and plutons.
Extrusive or volcanic igneous rock is produced when magma exits and cools above or very near the Earth's surface. These are the rocks that form when volcanoes erupt and fissures leak. When molten rock erupts on the surface, the magma, or also known as lava, cools and hardens almost instantly when exposed to the relatively cool temperature of the atmosphere. Because mineral crystals don't have much time to form due to rapid cooling, these rocks have an extremely fine-grained or even glassy structure. The 4 examples for extrusive rocks are basalt, andesite, rhyolite, and scoria. The second type of rocks is sedimentary rocks. These are formed by the compaction and cementing together of sediments, broken pieces of rock like sand, silt, or clay. It is also can be formed from weathering or erosion. In contrast to metamorphic and igneous rocks, which develop deep inside the earth, sedimentary rocks form on or near the surface. Erosion, weathering, dissolution, precipitation, and lithification are the most major geological processes that contribute to the formation of sedimentary rocks. The effects of wind and rain, which gradually break down large rocks into smaller ones, are included in erosion and weathering. Dissolution is a form of weathering. Water that is somewhat acidic progressively wears away stone in this process. These 3 processes provide the foundation for the formation of new sedimentary rocks. Precipitation and lithification are both processes that result in the formation of new rocks or minerals. Precipitation is the process through which chemicals precipitate from water to create rocks and minerals. Lastly, lithification is the gradual compacting of clay, sand, and other sediments on the oceans or other bodies of water's bottoms into rocks due to the weight of overlaying sediments. The example for sedimentary rocks are sandstone, limestone, and shale.
Metamorphic rocks. Metamorphic rocks are formed when the minerals in an existing rock are changed by heat or pressure within the earth. Examples are pyrite, schist, gneiss, quartzite, and marble. Metamorphic rocks are formed when rocks, sedimentary, igneous, and metamorphic, are subjected to high heat, high pressure, hot mineral, rich fluids, or more commonly, some combination of these factors deep within the earth or where tectonic plates meet. One way to tell if a rock sample is metamorphic is to see if the crystals within it are arranged in bands.
Next is pollated metamorphic rocks. Pollated metamorphic rocks have a layered or banded appearance that is produced by exposure to heat and directed pressure. Examples of pollated rocks include gneiss, pyrite, schist, and slate. Foliated rock is a type of metamorphic rock having identifiable layers, textures, and patterns. Extreme heat and pressure are applied to existing rocks to form metamorphic rocks. The change in direction of applied pressure causes layers in foliated rocks. The first example of foliated rock are gneiss. Gneiss is a common and widely distributed type of metamorphic rock. Gneiss is formed by high temperature and high pressure metamorphic processes acting on formations composed of igneous or sedimentary rocks. Gneiss forms at higher temperatures and pressures than schist. Next example of foliated rock are pyrite. Pyrite is a type of foliated metamorphic rock created from slate that is further metamorphosed so that very fine-grained white mica achieves a prepared orientation. It is primarily composed of quartz, cerussite mica, and chlorite. The next example is schist rock. Schist rock is a medium-grained metamorphic rock showing pronounced schistosity. This means that the rock is composed of mineral grains easily seen with a low power hand lens oriented in such a way that the rock is easily split into thin flakes or plates. And the last example of foliated rocks is slate rock. Slate is a fine-grained, foliated, homogeneous metamorphic rock derived from an original shale-type sedimentary rock composed of clay or volcanic ash through low-grade regional metamorphism. It is finest grained foliated metamorphic rock. It may mean a single roofing tile made of slate or a writing slate.
Non-foliated metamorphic rocks do not have a layered or banded appearance. Examples of non-foliated rocks include hornfels, marble, novaculite, quartzite, and skarn. Both foliated and non-foliated rocks begin their lives as either sedimentary, igneous, or another metamorphic rock. Due to geological changes, a metamorphic rock of the foliated or non-foliated type will be created. These geological changes can be due to heat and temperature from the crystallizing rock being found deep within the Earth's crust. A non-foliated rock will have almost the opposite texture. The minerals will appear to be randomly oriented without obvious banding and have a granular appearance. Unlike foliated rocks, there will be no layers and they will not flake apart into thin layers when broken. Non-foliated rocks contain more coarse-grained minerals and generally have a random shape. Because of this, these rocks are very granular in appearance.